Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yeah, and we are talking about one of our mutual favorite topics today, and that is space, or something involved in space. So, asteroids, actually. So let's get into it.
Really interesting. New research suggests that the origins of life may be tied not only to deep sea hydrothermal vents, but also to environments created by meteor impacts. Now, Scott and I have a certain belief about creation, and it could be possible that certain amoebas or something could be piggybacking on meteors and impacting and creating something. That's an entire possibility. Meteor strikes may have played a surprising role in the origin of life on Earth by generating hot, mineral-rich environments where early biological chemistry could develop, according to a scientific review led by a recent Rutgers University graduate. I can believe that too. They're not saying that man walked from the sea on two legs. They're just saying chemistry-rich environment for life to move forward. And I can see that. I believe that.
Yeah.
Would you like to know more?
And here we're going to start with a quote. No one knows from a scientific perspective how life could have been formed from an early Earth that had no life. And that's according to Shea Cinquapin.
Cinquemani.
Okay. Cinquemani, okay. Who earned her bachelor's degree in that Shea. Interesting. Okay, and it's a her. Bachelor's degree in marine biology and fisheries management from the Rutgers School of Environmental and Biological Sciences in May of last year. And how does something come from nothing? That was her.
That's a good question, Scott. We know how. Tell them how, Scott.
Well, yeah, we are all here in the image of our Father in heaven, and he created with the help of the Savior, he created the world.
Yes, sir.
And all that we know about it. So there you go.
Yes, sir. That's how you create something.
Cinquemani, is that how you pronounce it?
Cinquemani. You got to put your fist up like this. Put your fist up like this.
So do you think her first name is actually Shay?
Shay, yeah. That's
Shay,
a name.
Okay.
Cinquemani authored the review published in the Journal of Marine Science and Engineering on March 2nd, 2026, which examines where life may have first emerged. The study centers on hydrothermal vents, where heated, mineral-laden water moves through rock and enters surrounding water, creating energy gradients and chemical conditions that can drive complex reactions.
Her analysis highlights hydrothermal systems formed by meteor impacts as an overlooked but potentially important setting for life's beginnings. These systems may have been common on early Earth, making them strong candidates for where life first developed.
The paper was co-authored with Rutgers oceanographer Richard Lutz and stands out as an unusual accomplishment for an undergraduate researcher. What began as a classroom assignment ultimately became a peer-reviewed publication. Wow.
Okay, the work started during Cinquemani's senior year in a course titled Hydrothermal Vents, taught by Lutz, a distinguished professor in the Department of Marine and Coastal Sciences. Her original assignment explored whether similar vent systems on Mars could have supported life. Did we not talk about, we talked about some kind of thermal vents, I thought. One time, some kind of vents.
On
Maybe
Mars?
It was something else. I don't know.
No, we have talked about thermal vents down in the bottom of the ocean. Definitely, we have.
Yeah.
And how there's life,
right.
life is forming around it. Yeah.
Right.
Okay. After graduating, Lutz expanded the project into a broader review comparing impact-driven systems with deep-sea vents. The paper underwent an intensive review process before being accepted. Deep-sea hydrothermal vents have long been considered a likely setting for life's origin. Discovered in the late 1970s, these environments support entire ecosystems without sunlight. Instead of photosynthesis, microbes rely on chemical energy from substances such as hydrogen sulfide in a process known as chemosynthesis.
Some vents are fueled by heat from volcanic activity within Earth, while others result from chemical reactions between water and rock that produce heat without magma. In both cases, they create localized warm environments that support chemical activity on the otherwise cold ocean floor.
Cinque Mani's research places greater emphasis on hydrothermal systems triggered by meteor impacts, an area receiving increasing scientific interest. When a large meteor hits Earth, it releases extreme heat and melts nearby rock. As the crater cools and fills with water, it can form a hot, mineral-rich system similar to deep sea vents.
Okay. To understand how these environments might support life, she reviewed studies of 3 impact sites from different periods in Earth's history. These include the, Chicxulub crater and I'm sure I butchered that word, in Mexico, formed about 65 million years ago. The Houghton crater, or Houghton crater in the Canadian Arctic, formed about 31 million years ago, and the Lonar Lake in India, created about 50,000 years ago, still containing water today. Interesting.
Such systems can remain active for thousands to tens of thousands of years, giving simple chemical compounds time to evolve into more complex forms that could lead to life. Researchers suggest these environments may have been especially important on early Earth when asteroid impacts were far more frequent. Events typically viewed as destructive may also have created the right conditions for life to begin.
The idea builds on decades of work on deep sea vents while expanding the search for life's origins into new environments. Lutz contributed to early exploration of these systems decades ago. As a postdoctoral researcher, he joined some of the first expeditions to study hydrothermal vents and traveled more than a mile below the ocean. Wow, below the ocean surface in a submersible Alvin. What must be some kind of a submarine, huh? Where he observed thriving ecosystems in complete darkness. That is fascinating. That's a long way to go down.
These dives helped establish a new field of research and reshape scientific understanding of how life can exist without sunlight. Cinque Mani's work combines these established ideas with newer evidence suggesting the impact-driven systems could also support the chemical processes needed for life.
The findings also have implications beyond Earth. Hydrothermal activity is believed to exist beneath the icy surfaces of moons such as Europa and Enceladus, and may have occurred in ancient impact craters on Mars. If similar environments on Earth can support life form and chemistry, then they could guide future searches for life elsewhere.
For Cinque Mani, the research is fueled by curiosity. Humans are insanely curious beings, said Cinque Mani, who works as a technician at Rutgers New Jersey Aquaculture Innovation Center in Cape May, New Jersey, where she supports aquaculture research while preparing to pursue advanced study in marine science. Continuing her quote, "We question everything. We may never know exactly how we began, but we can try our best to understand how things might have occurred."
We question everything. That sounds like my parents.
There you have it. Scott's parents.
Yep, they questioned everything. I got away with very little, if anything. So, all right. Well, that was
Scott
a good
needs
one.
some therapy for that, as you can tell.
Yeah, it's really affected me. So, anyway, good one. We'll see y'all in the morning. Take care.
All right,
Thanks.
folks. See ya.